Hello and welcome to this episode. We're still continuing our discussion and our learnings on NumPy. And from the previous video where we spoke about broadcasting, you realize that it is not always possible for NumPy to automatically figure out how to perform broadcasting for you, especially if the shapes of the two arrays involved are not explicit enough. And I spoke to you about the fact that there will be many times where you have to ensure that your arrays and vectors have explicit shapes and sizes. So the whole idea of this video is to teach you how to reshape your arrays in explicit form so that you don't have these surprises once we begin to create neural networks using NumPy. And by the way, I also wish to mention that the API for NumPy is very similar to the APIs of TensorFlow and PyTorch. So whatever we are learning here mostly applies to TensorFlow and PyTorch as well. Of course, they all borrowed their APIs from NumPy. So it is very important that you know NumPy, and then you can transfer the knowledge from NumPy into PyTorch and TensorFlow once we start using them. So what I'm basically trying to say is once I start using PyTorch or TensorFlow to implement neural networks, I'm not going to spend a lot of time explaining the basic linear algebra stuff. I assume that you have watched these NumPy videos and you understand everything so that things can be a lot more smoother. Okay, so you can see that in practice, we often run into situations where existing arrays do not have the right shape to perform certain computations. And it is important that we have a way to reshape our arrays. And NumPy provides a reshape method that allows us to obtain a view of an array with a different shape. This is a mouthful. Let me go ahead and then use examples to explain as I have always done. So I'm waiting for Collabs to finish whatever it is doing. Okay, all right, great. So I'm going to create an array of size, let's say 100. And I'm just going to use a normal distribution. I mean, if you don't know what this is, watch my video on normal distribution, random numbers generation. So I'm going to say data is equal to numpy.random.normal. I want a normally distributed data with a mean of let's say 2.5, a standard deviation of 1.0, and I want 100 of them. Okay, great. Now let's print out data. This is taking a rather long time. Okay, so this is a normally distributed random generated array with 100 items. Let's see what shape it has. So say data.shape. So this is basically telling us that this is an array or a vector with 100 elements. Is it a row vector? Is it a column vector? It is none of them until we explicitly tell it to be so. Okay, so we have an array or a vector that contains 100 numbers. What if we want this to in a different shape? Okay, what is going to happen is we can reshape it. Okay, and then the way to do reshaping is we will store it into another variable. So let's say data1 is equal to data.reshape, and then you specify the new shape. Okay, so I'm going to say I want it to be 25 rows and then 4 columns each. So the most important thing you need to remember about reshaping is that when you reshape, you need to specify the values of your axis. I mean, the number of desired element along each axis, such that they still sum up to the number of elements in the original array. If I have a 25 rows by 4 column array, basically 25 times 4 is going to give me 100. So NumPy is going to be able to reshape this data up here to make it the way we want. So let's do this and let's print data1 and see. So you can see that unfortunately this was also printed with, okay, this was printed with 5 columns, 1 2 3 4 5, and see, this is 1 2 3 4. And now if I ask for the shape of data 1, I'll say data 1 dot shape, data 1 dot shape is a 25 by 4 array. Let's see data dot shape. And you see that data dot shape is still the vector with 100 elements. Now, the one thing I want you to remember is that when you reshape an array, the resulting array actually shares the same memory with the original array. So if I change anything in data 1, data is going to be changed. And if I change anything in data 1 is also going to be changed. It's just a different view of the same memory layout. The truth is, NumPy always does it best to store your values in a contiguous block of memory so that it can process it faster. It doesn't throw them around like what Python does with a vanilla list or other collection data type. So what NumPy is basically doing here is just rearranging things when it is returning to you, but actually the way it is stored is the same. It's the same 100 contiguous block of memory, but then data 1 has been restructured to look a certain way when you are using it. So they point to the same memory location. And so if I change data 1, it's going to change data. And if I change data, it's going to change data 1. This you must always remember. And you can verify this by saying np.mayShareMemory, mayShareMemory, and then you want to check that data, and data 1 share memory. Let's see what happens. It says true. So once you see this, it basically means that the value in data 1 and the value in data share the same memory. So if you change any of them, it is going to change the other guy. Okay, so let's go ahead and then do data dot reshape. And like I told you, when you reshape and you want the resulting array, you need to store it in another variable because the reshape doesn't happen in place. So if I call data dot reshape, let's say I want this to be 4 rows and then 25 columns, and then it will print it out. So you can see that now we have it's actually 4 rows. It is because of the way it has printed it, but then now we have 4 rows and then 25 columns. Let's see data dot shape. This is still 100. You might be wondering, didn't we reshape up here? We did, but I said it doesn't happen in place. So if you want the resulting array, then you need to store it. So I can say data2 is equal to this. And then now if I come and I check data2.shape, so data2.shape, then you can see that the shape of data2 is actually 4 rows and then 25 columns. It is very important that you keep this in mind, especially because you'll be having these challenges with broadcasting if you don't know how to reshape your array. Okay, so I'm going to create an array. A is equal to np.array, and I'm going to put in 1 2 3 4 5 6. Okay, let's check a.shape. It's basically a vector with 6 elements. We don't know whether it's a column vector, and a column vector is a vector that has only 1 column and n arrays. Okay, so I can reshape this by saying let's say a dot reshape, and I'll say I want this to be 6 by 1 specifically. So you can see that, you see the difference between a column vector and then a vector that has 6 elements. So like I explained in the previous video, a square bracket is what begins a new row. So this is basically an array with 6 rows and then 1 column. That is what makes it a column vector. What if I want to reshape this to have a 2 by 3? So I can say a.reshape, and then I'll say 2 by 3. And you can see that it has been reshaped, and then we have 2 by 3. Mind you, the reshape is not happening in place. So if we want to keep the reshaped version, the reshaped view, then we have to store it in another variable. Otherwise, underneath the hood, A is still a vector with just 6 elements. Okay. When we call reshape, it gives you a different view of the same data that is stored in the same memory location on your computer. Okay, so I mean, must we always be explicit about the sizes? A is a vector with 6 elements. So if I reshape and I have to make sure that the resulting size, I mean, is such that the number of elements is going to be the same as in the original, then I'm doing a bit of mathematics here. Okay, so NumPy is also smart enough to help us to reshape things without being explicit all the time. But like I've told you, always be explicit. It is better when people read your code and they understand than try to be clever and then disturb people. So I can say a.reshape 2 minus 1. And this actually achieves the same point here. The minus 1 basically tells NumPy that, dude, I want 2 rows. You figure out how many columns you need to be able to represent my, reshape my array in a way that is valid. So when you put -1, you're basically telling NumPy that I'm giving you this dimension of this axis. You figure out the rest based on how many elements you know there are in the array. So I can also say a.reshape. I can say -1 and then 2. So basically what's going to happen here is I'm creating a 3 by 2. Up here we created a 2 by 3. Now I'm creating a 3 by 2 because it is a 6 element array, and I'm telling NumPy that, dude, figure out the first the dimension of the first axis, which is your rows, but then I want the columns to be 2. So what happens here is you can see that we have 1, 2, 3, and that is how NumPy is able to figure out that the number or the dimension of the other axis that we have not specified. So I really want you to get this, let it sink deep down, think about it and understand it. I'm going to teach you a few more functions and then we will be done with this video. Okay, so what if I have an array? I mean, let me say b is equal to a.reshape. B is equal to a.reshape. I'm going to be explicit here. So if I check b.shape, you can see that b is a 2 by 3 array. What if I want to spread b out? I want to get it, I want to flatten it. Okay, this, if I print this, you see that it is a 2 by 3. What if I want to flatten it? Okay, that is easy to do. I can just say c is equal to b.reshape and I'll say -1. If you say -1, basically what you are telling NumPy is I want you to flatten it. No matter what the size is. This could be a 3D array, a 4D, a 5D, a 10D. It could be any n-dimensional array. Once you call reshape and then you pass -1, what you're basically telling NumPy to do is to just flatten it out. And so I hope you've understood it up until this point. Okay, now NumPy also makes it easy for us to flatten out arrays with a function called ravel. So b is a 2 by 3. If I say b.ravel, basically it's going to spread it out. If I say b.ravel, then it's going to spread it out. Okay, now I can also say b.flatten, and that is also going to spread it out. So you can either do reshape -1 or b.ravel or the NumPy array.flatten. Now you might be wondering, why do we have ravel and flatten? The difference is that unlike ravel, flatten returns a copy of the array. So if I call flatten on a NumPy array, the resulting restructured or reshaped array is just a copy. So if I change it, it's not going to affect the original array. To prove that, we already have a function called np.mayShareMemory, so we can verify this. So if I say b.ravel and then I say b.flatten, I expect that they don't share memory. because if you call b.ravel, it is going to reshape and return a view of the original array that has been reshaped to look the way you want it. But flatten will actually make a copy of it. I'm going to have a video on copying and stuff like that. But flatten will make a copy of it. So if you change the result from flatten, the result that you get from calling flatten on a numpy array, it doesn't actually affect the original memory arrangement of the array itself. So this, ladies and gentlemen, is what I want you to know about reshaping. And thank you for watching. Don't forget to subscribe, and I'll see you in the next video.